Hello, geometry class. I hope you had a restful April break. We are back learning about circles. Your quizzes are all graded. They were fantastic, so we're doing well with our distance learning. Today we're going to start section 4, chapter 10, which has to do with the angles created inside circles. So we're going to do some vocabulary. So your notes are in Classroom. I started by filling out some of the vocabulary. So an inscribed angle is an angle whose vertex is on a circle, so like there, and whose sides contain chords of the circle. So this is inscribed, these are the chords. So we say angle ABC is an inscribed angle. An intercepted arc is the arc that lies in the interior of an inscribed angle and endpoints on the angle. So if I look at here, AC is intercepted by these chords. So that is the intercepted arc. Lots of theorems today. Get excited. We're actually going to hit 1010. Theorem 10.7 says the measure of an inscribed angle equals half the measure of its intercepted arc. Okay, so if I look at this picture, the measure of angle ABC is going to be half the measure of the arc AC. Down here, theorem 10.8. If two inscribed angles of a circle intercept the same arc, then the angles are, that's right, congruent. All right, so if I looked at this, so you see here, let's say we had angle ABD. AD is its intercepted arc. Also this one, ACD, right? Same intercepted arc for both. Okay, so that means that the angles are congruent. So angle ABD is congruent to angle ACD. Okay, two new theorems. Let's keep going. We need some vocabulary. An inscribed polygon is a polygon with all of its vertices inside a circle. The circumscribed circle is the circle that contains the vertices. So I labeled here in the picture, you see inscribed, these polygons are inside the circle. So these are the inscribed polygons. The circles that contain them, those are the circumscribed circles. Okay, theorem 10.9. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Conversely, if one side of an inscribed triangle is the diameter of the circle, then the triangle is a right triangle, and the angle opposite the diameter is 90 degrees. And you can see my drawing from the other one. But if I look at this triangle, so this is a biconditional theorem. So the measure of angle ABC equals 90 degrees if and only if AC is the diameter of the circle. So because it's biconditional, both pieces, it can go back or forth. All right, here we are. As I promised, theorem 10.10. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So what that means is if I added the measure of angle D and the measure of angle F, that would be equal to the measure of E plus measure of angle G, which equals 180 degrees, right? So each one of those sums, so D plus F would be 180, E plus G, 180. Okay, so now let's apply it. Let's find the measure of arc BC. Well, I know that half the measure of arc BC equals the measure of angle BAC. Right? So this is half of that arc. So if I double, right, if I double the measure of angle BAC, I will get the measure of arc BC. So 74 degrees. Okay. Because it's an inscribed angle. Measure of angle A. Well, I see I have the measure of angle O. And if I remember what I learned in previous sections, that is my central angle. Okay. That means arc BC, right, this arc here, would be equal to the 132. Well, since BC is the intercepted arc of angle BAC, or angle A, then I know measure of angle A has to be half of that. So it's 66 degrees. Alrighty. Other side. Okay. Measure of arc AB. Well, I know this is 27 degrees, and this must be equal to this because they're both radii. So the base angles must be congruent. So if I find the measure of angle O, right, I do 27 plus 27, 54. 180 minus 54 is 126. So this must be 126 degrees. AB is the arc contained, right? And 126 is a central angle, so that's all I have to do. The measure of arc AB is 126 degrees. Measure of angle C on this one. Okay, again, these are radii, so this must be 28 degrees. 28 plus 28, 56. 180 minus 56, 124. All right, so that tells me this arc is 124. I'm looking for the measure of angle C. So angle C is the intercepted angle, or it's the inscribed angle for arc with the intercepted arc of AB. So angle C is going to be half the measure of arc AB. So it's going to be 62 degrees, half of 124. All right, so if you want to pause here and try solving these on your own and then come back and see the answers, that'd probably be good. I would start by measuring or marking what it is that they gave you. So here's my paper. Arc CD is 85, so I'm going to mark that. And the measure of arc BE, so this whole thing is 97. All right, so go to it and then come back and check if you're right. The measure of angle ABC. All right, it's going to be 9 degrees because this is the diameter. And we had our theorem 10.9 that said the angle would have to be 9 degrees. Because AC is a diameter. Okay, measure of angle CED. All right, the intercepted arc is this 85, so it's going to be half of 85 degrees, which is 42.5. Measure of angle BDE. All right, well, its intercepted arc is 97. So that's going to be half of 97, which is 48.5 degrees. CBD. All right, again, that's going to be half of 85 because this CD is the intercepted arc, so 42.5. Or you could use the congruent angles with the arcs. Measure of angle ABD. Okay. I know that all of this together, right? I want to find the measure of this arc. I know all of this together would have to be 180. So I'm going to do the 180 minus 85. That gives me 95. So that means that this arc here is 95. If I'm looking for ABD, that is the intercepted arc. So I'm going to do half of 95, 47.5. Angle BCE. Oh, I already have the 97, so this will be half of 97, 48.5. Measure of arc AD. Well, we had already figured that out before, right? We said 95 degrees. And the measure of arc ABC, well, that's a semicircle, right? Because it's opposite the diameter, so it's 180 degrees. Right, that's all I have for you today. So with the rest of this time, you should be doing page 666, numbers 1 through 15 odd. Have a great day.